Well, welcome and thanks for joining us to the NASA Sunset Show. We are coming to you live from NASA's Kennedy Space Center, Florida. Well, in a few hours, one of the greatest missions in history will take place. A mission to touch the sun. All systems are go. Launch is scheduled for 3:33 a.m. Eastern. We've got lots of coffee, we've got lots of energy, and we are ready. My name is Dwayne Brown.
And I am Karen Fox. And the star of the show, the sun, get it? Because the sun is a star.
A star. That's true, it's a star.
The sun is about to set, and we are getting ready here for that launch. And we have been talking about the sun the last few days and how Parker Solar Probe is going to go straight to the sun. Today, we're going to talk to you about why NASA cares about that.
Okay, I know I care. So, when you look up at the sun and look up at the sun with safety glasses, remember those eclipse glasses? We have some. I hope you guys have some. It looks calm and looks tranquil, but when we get close up with our space telescopes, it's dancing, it's dynamic, it's fury, it's mad, it's going a lot, and when it's doing all of this, it's sending out solar particles all throughout the solar system. Right?
And these solar particles, they go out, they are affecting planetary atmospheres, they can create space weather near Earth where they can interfere with GPS and radio communications. And so this is something that NASA wants to learn about.
And it also, this mission will help with our astronauts up at the International Space Station. When they go to the moon, we're going back to the moon, ladies and gentlemen, and of course eventually to Mars. All of this and much, much more. We're going to have a great show. We've got some incredible talent. Oh my goodness. And you need to send your questions in to hashtag AskNASA. Social media is a buzz. Hashtag AskNASA. We're going to get to as many questions as we can. And we are ready. You send those questions in. Again, hashtag AskNASA.
All right, let us get started. We have Dr. Jari Collada Vega here with us. She is a space scientist from NASA's Goddard Space Flight Center in Greenbelt, Maryland.
But you know what? I gotta say this. I'm sorry. Jody, the last time we were on stage together, it was last year for the total solar eclipse across America. You guys, I hope you saw that. If not, it's on YouTube and it's on everything else. NASA YouTube. It's so good to see you.
It's good to see you too.
I know you're excited. I know I'm excited about this mission.
I am very am.
It's really good to have you here.
Thank you for having me.
Start out by just telling us what space weather is.
Space weather is pretty much the conditions out in space that are dominated by the sun. Like Dwayne said, the sun from Earth is very quiet, but when you look at it from space, it's actually very dynamic. It creates the solar storms in forms of solar flares, abrupt eruptions of radiation, or CMEs, coronal mass ejections, which are expulsions of billions of particles from the solar corona. When these storms actually arrive at Earth, they can cause, instabilities on the Earth environment. Some people see this kind of instabilities in the form of auroras. But when that happens, that means there's the magnetic field is very disturbed. Parker is an essential mission for us to understand this kind of activity. And it's going to go straight to the corona where this originates so we can understand it better.
Well, I'm just so excited that you're here, Jody. But, the conditions on the sun are always changing. When we did the eclipse, I learned so much about the sun. But how does all of this affect life here on Earth?
It can affect it really directly. It can affect astronauts in space, the radiation from the sun, and it can actually affect also satellites, the instruments from the satellites that we use for our technology, radar communications, GPS signal. It can actually affect everything that we use for our technology nowadays. So Parker is going to be essential for us to understand these processes. It's going to go straight to the corona. And with that data that Parker is going to collect, we can actually validate and actually improve our models that we use for the space weather forecasting.
Wow, so this mission is very important.
It is very important.
And it impacts just about everybody on the planet.
Everybody, every society.
There you go. This mission is definitely something for you to learn about and do more about because it affects every living person on Earth.
So we have our first question that's already come in for you, Jari. Tell us, the question is, what happens if Parker Solar Probe flies through some of these space weather events near the sun?
Well, that would be very interesting to have. And actually, Parker is an engineer marvel. It's actually made up to actually, be protected from this kind of radiation. It has a 4.5-inch heat shield that is actually going to protect the instruments from this kind of radiation. And this heat shield is going to be amazing. It's actually the one that is on the side of the sun. It's going to be at 2,500 degrees Fahrenheit, but the side on the instrument is going to be actually at room temperature. So it's an amazing thing, and hopefully we'll get really good data that we actually need with this kind of activity.
Thank you so much. We are actually going to keep taking your questions. You can use the hashtag AskNASA for that. We will continue to take them throughout the show. And you can also get updates on Parker Solar Probe at nasa.gov/Parker. And of course, most importantly, we want you to get ready to watch this launch. Our TV coverage will start at 3 a.m. tomorrow morning. That's just in a very few hours. And you can watch that at nasa.gov/live.
Well, you know, we've got another person joining us, but I think we're going to go, you know, this is a big mission, and a big mission needs a big rocket. And we have a big rocket.
Yeah, we do.
United Launch Alliance's heavy, Delta Heavy, Delta 4 Heavy. I better get that right because they're going to be mad at me. Delta 4 Heavy, but it's big. It's going to light up the night. And you know what else? Another person lights up the night. The sitting is right now. That's Dr. Nikki Fox. We have a star, but she is our superstar here. So the project scientist for this incredible mission, welcome.
Thank you very much. And yes, our Delta 4 has just been, the building's just been rolled out, and she is sitting on the pad, ready to take us to space.
A big mission, a big rocket, big science. What is it going to do?
Big science, big science. So Parker Solar Probe is going to make huge differences in our science. We've done so much with the sun, from looking at it with all different wavelengths, with spacecraft in the solar wind, even as close in as Mercury. But really, by the time they get to see the solar wind, it's old. It's had all its excitement, and it's much more average. And so we have to get into this region to finally be able to unlock the mysteries of what is going on with our star.
So I want to go further into that, because the solar wind is, frankly, is the theme of our show today, right? I mean, the solar wind, it is filling up space, it's affecting Earth, that's what we're talking about. So why can't we study the solar wind from where we are? Why do we actually need to go to the sun to do that?
So the corona is full of mysteries, and you really can't unlock those mysteries without getting the in situ data, without actually going up and visiting. All this amazing physics is happening. The corona is 300 times hotter than the surface of the sun. Its atmosphere is continually expanding and accelerating and streaming away, bathing all the planets, and in fact shaping our entire solar system in its journey around the galaxy. But you have to get in there to really get those physics. Why on earth do you move away from the surface of a hot body and get hotter? It doesn't make sense. It's like water flowing uphill. It shouldn't happen. And so all this physics is happening, but we need to get in there to really be able to take those measurements. And so that's why we're doing this incredibly daring mission to surf the sun's corona.
You know, Dr. Fox, Jody was here talking about space weather. How is Parker going to help us understand that even better? Because a lot of people, we hear about it, and it's so important, and it affects a lot of stuff.
Absolutely. And so we do a very good job of predicting. You know, we see something happen on the sun, and we say, well, this is probably what's going to happen here at Earth. And we have models, large-scale models. And if you think of taking the sun and the Earth as one big model, there's a big missing piece in that model, the physics that's driving and powering the solar wind. We don't know exactly what physics that is. We don't know what processes are going on. And when we add that to the already good models we have, it's just going to be game-changing.
Thank you. We do have a question for you already come in as well. And the question is, if Parker Solar Probe is going to be millions of miles from the sun's surface, what part of the sun is it touching?
So it's touching the sun's corona. It is deep in the sun's corona. Yes, at 3.83 million miles, that may not sound that close, but if we put the Earth and the sun 1 meter apart, Parker Solar Probe would be 4 centimeters from the sun. And so not touching the surface of the sun, obviously there is no solid surface to actually touch, but touching deep into the atmosphere of the star as it emanates away.
I got it, you know, the 4 centimeters. Now, I'm a big football fan. Football season's around the corner. I heard an analogy about the goal line and all that. So,
put the Earth in one end zone and the sun in the other end zone. Parker Solar Probe tucks and runs to the 4-yard line in the red zone, knocking on the door for a touchdown. Let's go Ravens.
All right, 4-yard line. They're pretty good.
Right.
They're pretty good.
We may not have mentioned that Dr. Nikki Fox is with the Johns Hopkins University Applied Physics Laboratory, which is right near Baltimore, Maryland. All right, we are going to keep taking your questions. So please send them in to #AskNASA. We will take them throughout the show, and we're going to have everybody come back up at the end and answer even more of them. And again, if you're just tuning in, we are talking about NASA's Parker Solar Probe, a mission to touch the sun, which is launching just hours from now after the sun sets in the dark at 3:33 a.m. You can start watching our coverage at 3 a.m. at nasa.gov/live.
Well, we have another star here with us, Karen, and Dr. Jim Spann.
We have Dr.
Hello.
Jim Spann. Hello.
Hello.
Spann.
He is the chief scientist for heliophysics, so let me take a moment and tell you a little bit about heliophysics before he gets started.
Okay.
So, we've been talking about the solar wind, right? The solar wind, it affects these planetary atmospheres. It affects all of space. And NASA studies this, and it's called heliophysics. That's a research field called heliophysics, and that is Dr. Spann's specialty. So,
Yep. Well, we have been here a long time today, so we're getting all of these stars. But let's talk about heliophysics. The heliosphere, which affects a lot. There's a lot of these scientific terms, but Jim Spann is going to break it down to you. So, how does all of this fit into this Sun-Earth connection that affects every human being we've been talking about earlier?
So we talked about, or Nikki mentioned the fact that Parker Solar Probe is going to go straight in and into the inner atmosphere of the sun. And that's really where the solar wind is accelerated, even though we don't fully understand it. Parker's going to elucidate that fact. But it is also going to help us understand the solar wind as it expands and fills the space between the planets in our solar system. Mm-hmm. And what we understand from this is that, in fact, the solar system is not a vacuum. There is stuff out there, and those are electrified gases, those are charged particles, it's radiation. And so as we study that plasma and it interacts with the rest of the planets in the solar system, that is part of what solar heliophysics is about. And Parker it plays a key integral to help us understand that whole system.
So tell us a little bit more about how heliophysics studies that. We've got this big space system. How are you tracking what's going on?
So the science of heliophysics really addresses the connection between the sun, the planets, in particular our own home planet, Earth. And so we have a flotilla of spacecraft out there, over 20 spacecraft out there studying various regions, including near the Earth with a recently launched GOLD mission on a commercial satellite, an ICON mission, which is getting ready to be launched. It's going to study basically the boundary between the Earth's atmosphere and space. That's really, in terms of space weather, that's really where the rubber hits the road. And the impacts are right there. We have missions that are studying the boundary of our solar system with interstellar space. We have IBEX. We just recently selected a new mission called IMAP. All of these things, including missions within our magnetosphere. MMS is doing a fabulous job of really trying to understand the fundamental physics that Parker is going to sense as it goes in there. So we have a myriad of spacecraft doing this.
And here we are. We're doing this huge launch. Like, what could be better than this? I mean, what comes next? After this,
awesome.
What do we do?
Well, heliophysics has a plan where we are going to study various regions. Parker is going to really address the inner heliosphere as we study that. We've got a mission, as I just mentioned, IMAP, to study the boundary of the solar system with interstellar space. We've got another mission, Global Dynamics Coupling, or constellation, which is going to be studying the coupling between the ionosphere, which is right near the Earth's atmosphere, and the Earth's magnetosphere, which is the region that is dominated by the Earth's magnetic field. All of those regions are key to truly understanding the physics that really connects everything, as well as providing an understanding for space weather. And so that's kind of the applied component of heliophysics, and we are super excited about going after that.
I got to get a question in here because Jody was here. We're going to have another incredible scientist come up. And I just got to go back to the eclipse, 600 million or more. I mean, and another thing that touched just about everyone, particularly on the United States. But Jim, you guys have been pretty good and really busy. You had the eclipse last year. You got this. You guys, the solar scientists, I mean, the heliophysicists, they got to be like
Oh,
happy, man.
We are ecstatic. We are so excited about, because there are so many different aspects of this system, this connected system to study. We've got missions addressing various aspects, and then as the scientists, a lot of the scientists work on the missions themselves and build the instruments, and there's an entire community out there with young, early career folks who are studying the modeling, the connection between the two. It's just a very exciting time for heliophysics. I can't say enough about that.
Wow.
I'm excited too. I have to say, heliophysics is the field I focus on for NASA, and I'm having a great time with it. We do have a question for you too before we let you go. This is from Eric on Twitter. He says, I recently read about the Carrington event in 1865 where telegraph lines caught fire from a solar flare. Will Parker Solar Probe help us to know if a similar event is brewing?
Oh, absolutely. As Nikki mentioned, Parker is really going to help us understand the fundamental physics that provides the source of the solar wind and the explosions that are coming from the sun. Really understanding that acceleration process, that energization process. When those events occur and that energy is incident on the Earth, then events like Carrington can occur. Now, we've not had anything quite as significant since then, but we've seen indications that there are very large magnetic storms. We've had power outages in Quebec in 1989, and so we do understand that our technology, as we use our technology in space communications, we are susceptible to these sorts of things, as well as our power grid, where currents are induced in those power lines, and that's in essence what caused those telegraph lines to catch fire, and we are trying to understand that so we can better predict it. And Solar Probe plays a key role in that.
And I just want to check on one thing. But Parker Solar Probe won't be in real time telling us what's going on, right?
It's going to really help us understand the fundamental physics. And in that physics, as we input that physics into our models will become better predictors. And as we study all parts of this system, the data that we get from these missions fold into the models. They help us better understand. The models then provide information, which then again drives the next mission that we need to fly, so that we can again improve our models, continue to improve our understanding. As a result, we will have better prediction for space weather.
Well, you know, Parker may not tell us in real time, but let's see if we can do a real time picture of the launch vehicle again. I think let's go back to there. United Launch Alliance. You guys are awesome. A big rocket for a big mission with big science. We're here at the Sunset Show. Hashtag Ask NASA. Please send your questions in. Again, hashtag Ask NASA. Social media, they are exploding. Bring your questions in if we can't get to them right now. And of course, look at nasa.gov/live. Check that website out. The launch will be there. You're watching us here on that and much, much more. We are here at the Sunset Show. And, oh my goodness, look who's here.
Alex Young, Dr. Alex Young.
Another Eclipse.
My Eclipse friends.
I see you went to the barber like me.
That's
today,
right.
Yeah. Do the head, there we go. There we go. Alex Young is a solar scientist, right?
Correct.
NASA's Goddard Space Flight Center in Greenbelt, Maryland. You got the shoes on?
I do.
The man with the shoes. You know, you have been all over the place. I mean, you're just telling about this star. Why is this star so important?
Well, so, Nikki and Jari and Jim have done an amazing job talking about the fundamental physics that the sun drives and creating this heliosphere and the connectivity of all the planets. But one of the things that's also amazing is that the sun is a star. And so if we understand our star, which is the only star we can really look at up close, then we can understand other stars in the universe. I mean, I actually like to think of Parker Solar Probe as not only a heliophysics mission, but a universe mission. It tells us about the universe, the fundamental objects in the universe, stars. And so Nikki talked a lot about the solar wind and the environment that it creates, and other stars have winds too. We call them stellar winds. Mm-hmm. And they also create an environment around their particular solar systems. And so understanding this tells us about other solar systems. So there's solar systems where we know there are other planets. It tells us about the universe in a way that we would never be able to do. So getting up close and personal, understanding this fundamental physics is fundamental to our understanding of the universe we live in.
So I want to follow up on that. Let's talk a little bit more about this universe and what we're studying in the universe, because one of the things NASA's really trying to do, right, is see if there are other habitable planets out there. So are we saying that Parker Solar Probe has a connection to things like that?
Absolutely, absolutely. Heliophysics is the fundamental science of a solar system, of a stellar system. And so understanding the interaction between a star and all the planets is something that only Parker and what we do in our solar system can do for us. We know that other stars can be extremely active, too active because they blast planets with radiation and energy, or some stars can be too cool and don't have enough energy. We live in just the right solar system. It has just the right conditions that allow for habitability. And really to understand how that applies to everywhere else, we again have to go there up close and personal to really get a handle on that fundamental physics to understand our place in this bigger universe.
One other question, Alex. NASA, we're going back to the moon, then on to Mars, moon to Mars. How is this mission, and we talked earlier in the show, the astronauts and sending humans and all of the stuff that this mission will bring, all of the great science that pretty much covers a wide field. How will Parker help those initiatives to get us back on the moon and eventual footprints on Mars?
Well, as my fellow guests have talked about, the energy that the corona is driving particles to extreme energies. These particles create radiation storms, and that radiation is hazardous to astronauts. It creates a hazardous environment. So understanding how these magnetic fields in the corona, how the solar wind is accelerated, how shock waves are created and accelerate particles, tells us about these particle storms that make it to Earth or that make it to Mars and create this hostile, hazardous environment for human beings traveling in space. So this is another example of how we need to understand the fundamental physics, and this is the spacecraft, this is the mission that is going to do that for us.
This is a mission when people ask, why should we care? We got a whole bunch of answers.
we really do. And this is for me, and I know for many of my fellow heliophysicists, an amazing spacecraft that is both honoring an amazing physicist who has done seminal work for his entire career, which has laid the foundation for all the science we do, on top of the fact that this project is driven by unbelievably talented and amazing engineers who've created this, something that people have wanted to do for 60 years, and it's going to happen tomorrow morning.
Right, in 60 years, and the agency is celebrating 60 years.
Well,
the 60th
it's
anniversary. Pretty cool, right?
It's such a great confluence of events. So in 1958, Parker predicted the solar wind. We had Explorer 1 seeing the radiation belts. We had the beginnings of NASA. We have the committee that decided on what's the bucket list of what NASA's going to do, and this is it. We are filling the bucket, and so all of it is coming together in 60 years. So it is an unbelievable year.
If you're just joining us, we are coming to you live from the NASA Kennedy Space Center, the Sunset Show. And I tell you, the excitement is abuzz. And send your questions in social media. You guys, #AskNASA. Again, #AskNASA. And we're going to try to answer those questions. Launch is still scheduled for 3:33 a.m.
3:33 a.m. All right. Should we bring everybody else up?
I think we should bring everyone
I
up.
think we should
All right.
bring everybody
Again,
up.
bring those questions in to #AskNASA. And again, go to the website at nasa.gov/live and nasa.gov/Parker. And the spacecraft itself, it is a big spacecraft. Again, check everything out. Launch, still scheduled for Saturday morning, 3:33 a.m., nasa.gov/live, and send in those questions to #AskNASA. And then we got the band back together
We
here.
got
I see.
everybody up here. We've got a whole bunch of questions to ask you guys. You guys ready? I have a wonderful one from Manish from Twitter. Why is NASA launching Parker Solar Probe at night?
There's an answer I'm dying to give
Yeah,
to that.
give it,
I'm
give it,
actually
give it. I wanna
going
hear
to
it.
resist the urge to say that it's less hot. So we have to launch. The first thing that we need to do is fly past the planet Venus. And so Venus has to be in exactly the right location in the sky for us. And so for our trajectory to go straight to Venus, it's a 3:33 a.m. launch.
Tell us, because we actually didn't have a chance to talk about this. Why does it have to go by Venus?
It goes by Venus to do a gravity assist, and so we are launching with a huge launch energy with Delta IV Heavy, and then we have the upper stage that gives us 55% of our launch energy when we're outside the atmosphere. But we're going very fast. We want to be able to turn and make sure that we are going in towards Venus. In towards the sun. We don't want to be dragged around at all by the influence of the Earth. And so we use Venus to kind of give us a little handbrake turn. It slows us down just a little bit and really turns that orbit in towards focuses it in towards the sun. There you go.
I'm going to take the microphone this time. All right, this is a question for Alex, standing behind me. This is about the coronal heating problem. The question is, are our most accurate models of the sun too complex to run on computers? Or is it really that scientists expect that our models are missing fundamental pieces?
Well, so we have a couple of theories that do a very good job of explaining some of the aspects of coronal heating. So one of the aspects that we're looking forward to is really to gather the data we need to really pin it down. We know that there's magnetic energy released in the corona. There's waves, there's little tiny explosions that actually Eugene Parker coined nanoflares. So is it a combination of those? Is it one or the other? What are the details of this theory? So it's really a matter of fine-tuning the knobs of the physics to understand what's going on. I don't know if you want to elaborate on that at all, or...
I think you did a great job.
Okay.
Yeah.
Can I actually ask a question? Somebody
Sure.
tweeted me, and I want to ask you the question. It's not a hard question, but it's a cool question, no pun intended. Why is the corona millions of degrees, but the front of the spacecraft's only 2,500 degrees? So.
That's a great question. So 3 billion degree plasma, but it's not very dense. It's a very, very tenuous atmosphere. And so there just aren't a lot of particles there to be able to transfer the heat into the spacecraft. Most of our heating comes from the photons from the sun, which is why we have a whiter than white coating on the front of the heat shield. On a Florida day like we've had today, I'm really glad I have a white rental car and not a black one. And so the white actually helps to reflect off a lot of the energy. And so what actually couples in comes up to about 2,500 degrees Fahrenheit. But the rest of the spacecraft, as Yari noted, is at a very balmy 85 degrees Fahrenheit, a bit like right now.
I'm going to follow up on that question with another one from Bhargava of Twitter. How does the spacecraft make sure the shield stays facing the sun?
She is the smartest spacecraft ever. We put a ton of fault management or autonomy. It takes light 8 minutes to get from the sun to the Earth, so there's no way that we could joystick this spacecraft. If something bad happens, she has minutes to respond, so everything is programmed into that spacecraft. And that's one of the reasons we've had to wait so long to do this type of mission, in order to have miniaturization and the technology to enable us to do it. Think of what you hold in your hand with an iPhone compared to what was available in 1958. There are little sun sensors all around the body. They're not supposed to see the sun. When one of them does, she goes, oh, I'm not supposed to see that, and starts firing thrusters to kind of right that anomaly. So she's very fiercely independent.
Can I ask a question? I mean, it's okay, but I'm good.
All right,
I think testing coming. Yes, we're good.
All right.
I've got to ask you, Dr. Eugene Parker. I mean, just amazing, right? I mean,
Yes, amazing. And I actually got to take him up on the pad today, and he stood in front of that enormous Delta IV Heavy that is carrying his legacy up to the sun. And so it was very emotional. He is just the loveliest man. I've said in every interview I've done, humble, gracious, and forever telling people that it's other people who deserve the praise, not him. And yet, as Thomas Sabucan pointed out, 35 NASA missions have flown that are, really have gone after his science, and that's a huge thing. So having one that bears his name is awesome.
And this is the first time this has ever happened,
yes,
right?
this is a historic thing. First time NASA's ever named a mission after somebody during their lifetime. And it was a lovely moment yesterday when Thomas said, and the person that it's named after is sitting in the room right over there. It was a very cool moment.
A Nikki Fox probe is next.
I don't think I will ever do anything as smart as Gene Parker, and so I'd love it, but I don't think it's going to happen.
Well, you're a superstar. You're all a superstar, and I think so. I've been fiddling with my, I keep saying the Eclipse, guys, and I got 3 of these. So, let's pass these out, and we got a couple of more here. It's the sun is setting, and quite frankly, we have everyone have one.
Yeah,
well, I got one. Okay, now I have one. So here's one for it. The sun is setting. For those, if you're just joining us, you missed a treat, but you'll be able to see replays. This is our sunset show. And a historic mission is going to take place this morning in the wee hours. Launch time is scheduled to start at 3:33 a.m. The sun is setting on a spacecraft, and in fact, this will be the last sunset the Parker Solar Probe will ever see. And in honor of she's a she.
She is a she.
We're gonna put on our eclipse glasses, and we're going to do one thing and give a shout out on 3, 2, 1. With 3, 2, 1, go Parker Probe!